Hello again, everybody. Welcome back to a new screencast lecture. Today's exciting topic is convection. Let's get started. There are three energy transfer methods. They are conduction, convection, and radiation. Today, of course, we are discussing convection. Let's first start with a definition for convection. Convection is the transfer of heat by the flow of particles, and it is requiring a fluid medium. That's key, fluid medium. So what is a fluid? A fluid is defined as a substance that has no fixed shape. The particles in the substance can flow. So think of fluid, think of flowing. What types of substances are considered fluid? So in other words, what type of substances can flow? Well, liquids. Liquids can flow. You pour a glass of water, it flows. And then, of course, there's gases. Gases can flow. That may seem kind of strange, but they can. If they flow, they can move around and change position. A gas can definitely float, move around, and change position. If you take your hand, you can push the air around you out of the way. The gas is flowing around your hand. Here's a clip showing convection. You have warm red water and colder blue water. Let's see how they interact. Notice the warmer red water rises quickly to the top, whereas the colder blue water sinks to the bottom. The colder blue water sinks to the bottom, pushes the warmer red water out of the way. Convection. So what happened? Why did it happen that way? The warmer fluid, in this case the red water, will rise, and the cooler fluid, in this case the blue water, will sink. The warmer fluid is what? If it rises, if it floats in the cooler fluid, well then the warmer fluid must be less dense and the cooler fluid must be more dense. The more dense fluid is going to sink, whereas the less dense fluid is going to rise. Eventually the fluids will mix together and become the same temperature, and that's why you saw that purplish color. So the red and the blue are going to become purple. Let's repeat watching that video again and watch for that swirling effect. Okay, let's talk about that. Well, cool water is dropped into the tank. Let's represent that with this blue. The tank water is warmer in relation to the water that I just dropped in. Cooler water is more dense than the surrounding fluid, which is warmer, so it's going to sink. We are heating up the tank in this area, so this area is going to be the most warm. That cooler water is going to keep sinking since it's more dense than the surrounding fluids. It's going to keep sinking. As it approaches the heat source, it's going to start warming up. So this is getting a little bit warmer than it was. As it gets warmer and warmer, it's starting to heat up. Now it's red hot. As it warms up, the warmer water becomes less dense than the surrounding fluid and floats back up to the top. So as this water mass gets more warm, it's going to spread out more and it's going to become less dense. It's going to float. So you see it rising up. As it gets to the top, what's going to happen? Well, as it gets to the top, that warm water is going to lose some energy. It's going to cool it. It's going to become more dense, and then it's going to sink back down again. This process continues, and it's called a what? Well, we have warm water floating, goes up to the top of the surface, cools down and sinks. Cooler water sinks, warms up again, rises, cools down and sinks, so on and so forth. So it's some sort of a cycle. This is called a convection current. You may be familiar with the saying that hot air rises. I'm sure you've heard that. Here's a clip showing sparks in a campfire that they're going to be rising as that warm campfire hits the cooler air. One of the cool things you can do with this idea of rising warm air is hot air balloons. Let's take a look at this clip showing a hot air balloon being filled up with hot air. Pretty cool. I've never had that opportunity to go up on a hot air balloon. Maybe you have. If you have, comment down below. Let us know what it was like. All right, we mentioned the phrase hot air rises. Well, I kind of like to think of it in a little bit different way. I like to say that warmer air floats in cooler air. That means that the less dense air mass is going to float in the more dense air mass. Here we see a picture of dry ice put in water. That dry ice is going to sublime. That's frozen carbon dioxide. It's very, very cold. The air surrounding is going to become very cold. That cold air is going to sink in the warmer air. All this that you see here, this is water vapor that's condensing in that cold air mass. But do you see how it sinks? It doesn't rise, it sinks. Carbon dioxide is more dense than the surrounding air. This is a cool clip showing that of a cold air mass going up and falling down a mountain. Almost like an avalanche, but that's a cold air mass with water vapor that is condensed. Basically, it's a cloud falling down the mountain, sinking. Here we see a diagram of a chimney. The way a chimney works is based on this convection as well, where you have warm air rising, less dense warm air rising in the cooler air mass. Here you have fire. The fire warms up the air above it. The warm air spreads out, becomes less dense, and rises up through the chimney. The cooler air inside the room is going to come and take the place of the warmer air that just left. Here's the same basic idea, but now we have a chair on fire. We have a house fire. So the air above the fire is going to be warmest. That warm air is going to rise, and it's going to hit the ceiling. It can't go any further, so it's going to start spreading out throughout the ceiling. The firefighter comes in. He's crawling. He's staying down low because he wants to avoid this very, very hot air up above. The hot air comes up and can escape out the doorway. That means that there's going to be less air pressure inside than there was. So now this cold air mass, which is more dense, is going to rush in, go over to the fire, make it burn more, give it more oxygen. That air is going to rise, and that's going to be a convection current. Cool air rushing in, warm air rising and leaving the room. Here's a clip showing this in action. You can see the dark, warm air layering up towards the ceiling. That's unburned fuel. Sometimes you can see flames flickering through that unburned fuel as now it's burning. Firefighters call that ghosting. This one's going to take a little bit longer. This one is based on a cigarette falling in a sofa. Well, that's all the time we have for tonight. Hope you learned something. If you liked this video, give it a thumbs up. If you didn't like it, give it thumbs down. Of course, always subscribe. Catch you next time. See ya!